Okay, welcome everybody. So this is IDS 410 databases. And today we're just going to go through the syllabus, talk about the course a little bit, make a dent in the first lecture. That is our plan. And on Thursday, we'll finish chapter 1. Okay, so let's go. So this is the course. This is what we are. We meet here. We meet now. I'm not sure why they switched us out of SES to D1, but I am grateful for the change. It's much more convenient for me, hopefully for you as well. So that's nice. And we meet now. So I got to change this. So let's go ahead. We'll make that update. Lecture Center D1. Okay. I'm going to save that as version 1.1. Okay, cool. I'm Doug Lundquist, whatever. You can call me Doug. That's fine. It's actually, I prefer it. We all have names and it's not that big of a deal for me. So whatever. But if you're uncomfortable with that, as many students are, Professor is fine. Professor Doug, Professor Lundquist, Dr. Lundquist, all fine. If you want to use a title but insist on using the wrong one, you could call me Mr. Lundquist, but whatever. Doug is fine. Doug is preferred. We're all just people. This is my email. You may notice that I have a student email. That's because I am a UIC alumnus. So I did 2 years in Champaign-Urbana many years ago, then dropped out and spent 10 years doing other stuff. And then I decided to come back to school at UIC because I was living in Chicago at the time. I have this. Now, even though I've been here for many years, you know, the administration people, they would not give me a cooler net ID, so I'm stuck with this. That's life. My office is 2424 UH, which is a wonderful thing because it's a very easy to remember number. And my office hours are TBD. Eventually, I will decide on some and make them available. But the good news for you is I am on campus 5 days a week. So generally, I have some availability around lunchtime. So I'll make it work. But there's usually not any super urgent concerns this early in the course that can't be handled through email anyway. We are going to have a teaching assistant for the course. I have not yet been informed about the identity of this person, but once I get that information, I can update the syllabus with that as well. So there's that. Okay, questions on any of that? Okay, so first of all, I'd like to give an overall disclaimer for this course. So myself personally, many of the faculty here, most of the faculty, in fact, they do a lot of research and then they'll teach like one course a semester or sometimes once every other semester. And so they're very much specialists in whatever they do, and that's fine. And teaching is a minor thing. For me, I'm the opposite. I do virtually no research. I put out a paper on Bitcoin a couple of years ago, but that's about it. And, you know, so I haven't done much publishing in the last 5 years or so. And I teach extensively. In fact, I probably have the department record with the greatest variety of courses taught. So this is my 8th course I've taught. And what usually happens with senior faculty is they get hired, they teach one course that they're a specialist in, and they just hang on to that course for like 10, 15, 20 years. Maybe partway through, they got to switch to something else. But if you're only teaching one course at a time, like a lot of these research guys are, you're never going to pick up many courses. I, on the other hand, I started out after I finished my bachelor's here, I rolled into a PhD program and then became a postdoc. And gradually they bumped up my participation until I was full-time faculty, which I am now, which is great. Okay, but that's why I have so many courses. I have not taught this course before. This is my first time through. I did take this course about 20 years ago, and being, you know, a MIS, IDS kind of guy, obviously I have, you know, knowledge of databases, but I just want to let you know that at any given moment, I'm probably going to be about 4 weeks ahead of where the course actually is, right? So I prepped up, you know, on the first quarter or so of the course over break. I'm going to keep up with it as time goes on. But what I can tell you, I will definitely have enough knowledge to teach this course effectively. If you have super specialist questions about the state of databases in the universe, I might not be the guy to go to about that. Okay? So let's be realistic here. They threw this at me last minute, like literally end of November, maybe early December. They said, hey, Doug, you're going to teach IDS 410 next spring. And I was like, what? But here we are. Okay. The good news for that is anytime I do a first iteration of a course, I expect things to go slightly off the rails. So we'll be forgiving about any kind of mistakes that happen, right? I'll do my best and it should be fine, but some troubles are bound to happen. Okay. Now, general information for the course. Databases are important. Okay. Obviously, businesses that have data, they have to keep that data somewhere. They have to make it accessible to many users. That's where databases come in. So that's super, super important. And what we're going to talk about specific things like the entity relationship modeling that we'll actually talk a little bit about this first week, conceptual versus relational data models, and then mapping them to specific hardware configurations. That's like a big thing that stretches out over multiple lectures. And of course, cloud stuff, because cloud is important, and alternative things like NoSQL databases and object storage systems. We don't go into detail in those, but I can talk about them. Anybody take IDS? Who took IDS 200 with me? Yeah. Okay. So all that kind of database stuff we talk about in that, this is, you know, a much more technical approach to it all. Okay. Obviously, it's a course around databases, so it's much more detailed. But, you know, hopefully some of this is, which classroom are you in? Oh, that's a good question. That is a good question. We are in Lecture Center D1. Okay. That's the best question I've had all week. All right. Okay. So we'll talk about a lot of database stuff. There is a schedule at the end of the slot, at the end of the syllabus, and we should follow pretty closely with that. Also, this is not the course I developed, right? So this is the course Professor Mohammed Mustafa. He covers this one, and he developed it, and his setup was that, well, there's some slack built into the system, right? So he doesn't follow quite as closely with this. I mean, like I said, basically some slack is built into the course progression. I do not plan on there being slack. I figure if there is slack, then, you know, class will just end a little early that day. So we'll see how it goes. That's my general approach to slack. All right. So what else? There is a textbook, right? This is the copy I scored on Amazon. I don't know, it cost something like $75. It is my understanding that the textbook is optional, right? And I'm not saying don't buy it, but I am saying it's a really interesting look into textbook development. So this particular one, this has been around for a few decades. I read the first, my family and I, we went out to California for a week towards the end of winter break, you know, like after Christmas, got back after New Year's. And while I was on the plane, it's like a 4-hour trip. While I was on the plane, I read some chapters of this. And first of all, I'd like to present my credentials as someone who can tolerate a lot of what normal humans would think is super boring. For example, when I was in 5th grade at our little school library, I checked out a book on radium. You know, the element radium? I checked out a book on radium, and not only did I read it, I enjoyed it. So this is cool, radium, right? However, this book, oh man, I would read that radium book 10 times before I read a chapter of this. Okay? So also, it's an interesting look in textbook development because there is useful information in here, but the presentation is really, really long because why? Because publishers get paid by the page, right? If this were a third of the size, they'd probably get about a third of the money. So they have no incentive to keep stuff brief and sensible, right? That's part of the pain. Also, textbook development stuff, it's neat because it's been around for decades, right? And you know that textbook writers do occasionally update their materials, but generally they don't update the whole thing, right? So they'll update specific technical aspects of it. And so when you're reading this, you'll find some very strange references. Anybody know what Sarbanes-Oxley is? Yeah, tell me about it.
A law that came out. It comes up at work all the time.
Sure.
I know the words and I know it comes up in GS.
Yeah. Well, I'll follow up with this. So it's a piece of legislation that controls how businesses have to handle data. That's part of it, right? Part of it. Okay. And when approximately, what was Sarbanes-Oxley a response to? You ought to know this one.
Enron?
Enron, excellent. Right. So if you haven't heard of Enron, you heard of it now. It was a big thing 20 years ago. All right. What about HIPAA? Anybody know what HIPAA is? Yeah, what's HIPAA?
It's like, has privacy and health data.
Yeah, something like Health Information Patient Privacy Act, something like that. Okay. And HIPAA came out about 20 years ago as well. So there's a spot in the book where they mention recent legislation like Sarbanes-Oxley and HIPAA. And I'm like, you could have at least gotten rid of the word recent there, guys. There's another thing. Has anyone here ever rented a physical movie, not by streaming, but like gone into a Blockbuster and said, yeah, yeah. There's a bit in this book that says, suppose you and your friends are going out to the video rental store to get a video for the, I bet like most of my students have never even seen a video rental operation, right? Or at least not within their living memory. So it's very strange. There's stuff like that peppered throughout the book. There's outdated technical references. You know, I expect to be reading this at some point and read something like, well, we don't have cloud yet, but we expect to have it in the next couple decades, right? So anyway, if you do get the textbook and you do read it, be prepared for that. You know, there's a lot of that kind of weird, hey, you guys all made it. All right. Yeah, I figured. I figured there'd be a sequence of people. What's up? Okay. So there's that, right? So there is a textbook. Like I said, it is not my understanding that you need to own it. And it is not the most enjoyable thing to read, even as textbooks go. Okay. All right. So anyway, there's that. We use Blackboard like we saw today. It's important to check the announcements because, right? Blackboard announcements like where the lecture is going to be. That's a good thing. Thank you all for making it, though. Sorry for the trouble. I just found out about that this morning that, oh, by the way, your course is going to be held here instead of there. So there's a last minute thing for me, too. Okay. Email. Because I'm one of those professors who teaches, I typically have several hundred students every semester. I think this semester the head count is 450. Okay, so I get a lot of students, which on occasion generates a lot of emails. So I try to respond to emails quickly within 24 hours, often much sooner. I was a little bit backlogged because start of the semester is a little busy, but I'm caught up with all my email during the break, during my break between classes today. But yeah, so I try to respond to email quickly. Okay, and if you haven't heard back from me within a couple hours, chances are somehow it got lost, right? Either I was looking at your email and thinking about how to respond when something came up and I didn't get back to it, or I missed it, or on occasion a spam filter can get it, whatever, something. If you haven't heard from me in 48 hours, please, ask again, and that's that. Of course, as always, common sense applies, right? For example, if there's a homework assignment due Friday at 11:59 p.m., don't think I'm sitting by my computer with my email open at 11 p.m. waiting to respond, right? Right. Okay. Also, since I teach multiple courses, right? If you are emailing me, please include what course you're on, either in the subject line or somewhere in the message. Hey, professor, I'm in, your IDS 410 class and I have this question, right? Otherwise, if you send me an email like, hey, what did we cover in today's class? I'll be like, well, that depends. Which of my courses are you taking? Okay. And we'll have wasted each other's time a little bit. And we don't need to do that. Okay. Last thing, students with disabilities. If you have a documented learning or significant medical disability, please contact the Disability Resource Center, which exists to help those kind of students have a level academic playing field. Okay. And then you can get what's called a letter of accommodation that gives you, whatever things you need, like extensions on assignments if you need them, extra time for exams, stuff like that. And most of these DRC accommodations aren't super serious, but some of them are. A few years ago, I actually had a student with a DRC accommodation who died during the course of the semester. So, faculty take these things very seriously because sometimes they are very serious. Okay. Anyway. So there's that. Questions about any of that? Any of that kind of front page stuff? In general, I'm not super formal. So if you have a question, my thought is if you have a question, you can kind of just shout it out because number one, there usually are not that many questions. And number two, then, we don't have to go through the whole formality of you raising my hand and me calling on you, you student, you may speak, right? Because that's time out of our lives we're not getting back. Okay. All right. So grading, there's a bunch of stuff. There's going to be some homework assignments. There's going to be some exercise. Oh, I should admit, it's not really here, like in this part. You'll be doing some stuff with Amazon Cloud, Amazon Web Services, right? So there's one thing that I got to contact with the people today and get all that set up. I should have it up and running by Thursday, can talk about it. So basically, there's some online training exercises you can do. There's one that's like basically a very basic intro to cloud, similar to what we did in IDS 200, not much more than that. And then, so you can complete that. And then later on, there'll be some exercises that you do with cloud-based databases, again, with Amazon Web Services. So we're trying to provide some, commercially useful skills here. Okay, and that's what these cloud data labs are. There will be a midterm exam. I've seen the midterm exam. The other professor puts up a similar copy. I can fire that up for you now. I have access to his fall 2023. And like I said, if you look at this thing, you can see a lot of it is terms and definitions. Some of it is prior tests. Ooh, that is the midterm. Oh, that's hidden. Course documents must be here. Prior edition, sample edition, midterm review. Sample exam questions, let's do it. Sample midterm exam, okay. So my point is not to go over this content, but just to demo, this is very much kind of a terms and definitions type course. Okay, so again, if you've taken courses with me, you'll know that's not really the way, but an attribute that uniquely identifies an entity consists of a composite attribute is called a something. A value that indicates the date or time of data, right? Stuff like that. There's a lot of terms. It's not all terms and definitions, but there is a lot of that. Okay. Anyway, but we'll see, though. We'll have more on that. We have a lot of content to cover before we get to the exam. But if you just want an idea of what the style of the exam is going to be, there it is. I'll make that available for you as well. Okay. And then there's a final exam. I haven't looked at it, but I imagine it's going to be pretty similar. Style tends to remain the same across the course. There's also a discussion board later in the course. We're going to fire that up. And the idea there is there are many students who may be having trouble with various aspects of assignments and homework, and there are other students who may help them. And so we'll have a discussion board where basically you participate and in some requisite number of hosts. And if you get 10, then that's considered sufficient and you get credit for it. Okay, so that's what the discussion board is. I should mention, the other instructor mentioned to me that one important feature of that is just to lighten the load on the TAs and instructors, right? Because there's a lot of you with a lot of questions and yeah. Okay. Grades, we shall see. There may be a curve, but is the nature of curves that grades cannot be, curves cannot be predicted in advance of all the grades coming in. So I guess we'll see. I do plan on having my grade distribution aligned pretty closely with the other instructors, right? It wouldn't make sense for him to have like 70% A's and me to have 70% C's, something like that. So it's not going to be a perfect one-to-one correspondence, but yeah, it'll be pretty close. So we'll see how it goes. Okay, and course administration, number 3, this is basically don't cheat, okay? Which, I shouldn't have to tell you, but here's the thing. Cheating is sometimes kind of a gray area. So obviously, it's totally fine to ask other students, hey, how did you do this? I'm stuck at this one point on the assignment. How did you do it, right? That's totally fine. It's totally fine to put up a post on a discussion board and say, gosh, I'm stuck at this point of the assignment. How, who can help me? And it's totally fine to go to something like Stack Overflow and say, I'm stuck with you guys know about Stack Overflow, right? It is your friend. It is totally fine to go to Stack Overflow and post a question and get a response, right? These are all sensible uses of outside resources. Where it becomes a problem is if, it's 11 p.m. and the assignment's due an hour and you've just been Netflix binging all week and you send an email to your buddy saying, gosh, I didn't do any of this shit. I don't know what's going on. Can you just email me a copy of your homework so I can submit it, right? Obviously, that's a problem. Now, we don't try to be, you know, all Sherlock Holmes about this because we don't have enough hours in the week to track all these things in detail. However, we're trying to teach you worthwhile, useful job skills, right? I assume that everyone in here is here because they're an IDS major or at least a minor. So you're going to be doing shit with databases, right? You might as well actually do it, right? And I get it. There's always a temptation to whatever. I'll learn it whenever I get hired somewhere, but it's better to have the experience. Just saying. So, you know, there's that. Okay, and this is the schedule, right? Which again, we'll cover some of this stuff when we get closer to it. So the AWS cloud stuff, all those things are going to be arriving a little later in the course. Okay, so no need to worry about any of that. What there is right now, there's some reading, there's some slides, there's me talking. Eventually there'll be some homework stuff, but that's, you know, again, not till a little later. All right, cool. Questions?
Yeah, do you expect this to be readings, or do you expect to go over those sections from those pages?
I do not, like I said, it is my understanding that the textbook is optional. And since it is optional, I can't really expect people to do the readings. It's great if you do, you know? And again, I applaud your intellectual strength. If you can, you know, plod through one of those chapters, they get a little better. I mean, the first ones are kind of rough, but, you know, I looked at some of the later ones are shorter and a little bit more compact and focused, and so it's good. But yeah, those first ones are rough to go through, right? You can see this one's like 50 pages. This one's like 60 pages. Ugh. But they get, you know, here it's like 30, and well, that one's brutal. That one's brutal. 18 pages. That's my 19 pages. That's my kind of chapter. Okay. All right. All right. So yeah, you know, if you want to get the textbook and read it, and you know, some people like having a book, like if you take the train to campus or something, you can flip through it and look at terms and definitions, whatever. Okay, but the slides, you know, and what I talk about should have the stuff. Now, the nice thing, these slides, which I will have to post, they do have some notes underneath, right? And sometimes those notes are relevant. Again, keywords, things like that are, you know, appear in there. So not just what I have in the slides, but also the things below. Okay. So no questions, nothing else? Anything else? All right. Okay. So this is chapter 1, database environment and development process. We'll just talk a little bit today about, you know, how things used to be. It's kind of strange at how much detail this book goes into, and basically what would happen if you didn't have databases as such, but it does. So I'll play along. So learning objectives, you know, any terms that come up, you should be able to define the terms, right? Those will happen on exams. Limitations of conventional file processing. That's what we're going to talk about. This is kind of like pre-database era stuff, and it's not totally gone. So we'll talk about that too. And advantages of databases. We'll get into a little bit of that. There's some other things, costs and risks, operational, informational, components of database environment, blah, and a lot of other stuff. Okay, so anything that shows up here, you ought to know what this stuff is. There are questions in the back of the chapters, although there's a lot of, you know, questions elsewhere too. So that, you know, is one potential thing. Although, unless you get the instructor version, it doesn't actually have the answers, right? But, yeah, man. It's very strange, you know, looking at the, if you know how sometimes a textbook at the end of a chapter, they'll have like a list of references. So they seem, yeah, very serious and academic. Yeah. So I'm looking through this references at the end of this first chapter. Literally, the most recent one is from 2011. No, there's a 2014. There's a 2014 is the most recent one. There's a 2011. Before that, the next recent, there's a couple 2005s and a 2004. Oh, there's one 2016. That's nice. Okay. And there are some ones from the 90s, and there's one from 1970, which is about this old stuff. So it's kind of, you know, what can I say, right? It's an old textbook that has not thoroughly been updated. So there's that. Okay. Well, terms and definitions, we'll make a dent. We'll get like about, I don't know, a third of the way through, make it to like slide 15, 16, something like that. So key definitions, these are all things you should know. So a database is an organization of logically related data. Okay? I think I have access on this. Do I have access? Good. Okay. So if you've done all the stuff in, let's see what we have here. If you've done all the stuff from IDS 210, right? Because if you took, or not 210, 200, the labs are all the same regardless of who you took it with, right? So here we can bring up tables, right? We have a table called customer, and for every customer, there's a first name, last name, phone number, street address, and so on. We have zip codes, right? For every zip code, there's a number, and then there's a city that goes with it, right? So there's data here, but it's organized, right? It's organized into what are called records. Like each specific zip code would be a record, or each specific customer would be a record. And every individual record has fields or attributes, right? Some things, textbooks call it fields. This one tends to call them attributes, but basically the variables. So for every customer, you have an attribute of first name, attribute of last name, attribute phone number, and so on, okay? So there's all the data there, but it's organized, right? And the alternative is, let's see if I can, no, I can't even do that. Let me do this. Would be like if you took all of this raw data and just plugged it into a notepad file, right? Some plain text file. It would be hard to find what you're looking for. But the fact that it's in database software and organized makes it very easy to find what you're looking for. So that's really the selling point. Okay, now data, they say here, stored representations of meaningful objects and events. And there are two kinds, structured and unstructured. So structured basically means there's a very clear and consistent format for any piece of data you want to look at, right? So for example, if you, oh, good time for a question. Who's taken IDS 201 with me? Not taking it now, but who has taken, okay. So how big is an int variable in Java? Ah, you didn't think you were going to get Java trivia today. Ah, how big is an int? How many bytes? It's 4 bytes, okay? It's 4 bytes. So if you are storing numbers as a standard integer format, right, you know that everyone is going to be 4 bytes. If you are storing it as a long integer, it's probably going to be 8 bytes, right? If you are storing text, right, as long as the text fields are formatted, and like one of the things in Access is generally you set a field size, like you might say the last name can be no more than 30 characters, and the first name can be no more than 20 characters, right? It can be fixed that way, it can be structured. And dates, once you've settled on a specific format for a date, like whether it's long form, short form, something else, right? It'll have a specific format. So you'll know exactly how big it's going to be, which is important in databases for like figuring out storage capacity. Unstructured data, on the other hand, is something that you usually can't apply a specific format to, right? So for example, suppose you had a bunch of videos. How big could a video be? What would be the biggest size video you'd probably expect to see as a unit? Maybe a couple gigs, right? Probably not bigger than that, probably, okay? Sure, but it depends, right? If you have a very long video and it's recorded in the new cutting edge 4K format, it's probably going to take up more data space, right? Especially if it's designed with super pixelation to, look good on big screens. It's going to take a lot more space than some, grainy, VGA graphics thing from the 90s. It's a lot, right? Because back in the 90s, we got videos that were like 3 minutes long and a box this big, and they played for a few minutes. They were a couple megs long, and we were happy to have them. Okay, so videos could potentially be relatively small, right? Or very big. Likewise, documents. Some documents are going to be very big, right? Other documents could be short. There's not really a standard way to fit a size on a document, like a web page, for example. Some web pages could have a whole lot of HTML and other stuff and be very long documents. Others could be pretty compact. Now, images are a funny one to a greater extent than videos, right? So there are ways to create these things as structured data, right? If you say very specifically, for example, an image will be 100 by 100 pixels, and it will be in, your RGBA 4 byte per pixel format, then yeah, then it becomes structured data, right? Because there's a definite format to it. But most of the time, if you have a collection of images, they're probably not going to be a definite format. Okay, so but that's what we mean. Structured data has a definite structure, definite format. Unstructured, one of these things might not be like the others. Does that make sense? I hope. Okay. Also, as is typical in basic MIS courses, the definitions cover information versus data, right? So data is just the raw stuff you have, right? Basically the numbers, the text, the image, whatever. Information has somehow been processed and formatted so it makes more sense to humans, right? So the picture they have here on the side, basically see a hard drive with a box with a bunch of little numbers below it. And, that would be just data, right? If there's a whole long list of numbers, that's not really going to mean much to you. But if you apply some structure to it and you say, hey, these are a list of zip codes, and the number next to each zip code is going to be, say, the population in it, or the average income, or the number of people with dogs, I don't know, something like that, then it's become information, right? So the transition from data to information doesn't change what's stored there. It's changing how it's organized and presented and more useful for humans. All right. Metadata is some kind of data that describes properties and context of user data. So easy examples, I have this table, I call it customer. As far as the functionality of the table, it doesn't matter what I call it. I could call it customers, I could call it people, I could call it clients, I could call it buyers. Doesn't matter, right? The table's going to hold the same data. So in a sense, customer, the name of the table, is metadata. It's what describes what's there. Other things, like if I say this last name field, that's going to have a max size of 32 and say a minimum size of 4 characters. That's metadata, right? It's data that specifies how that field is going to be in that table. So ordinary data is just stuff that's stored in these tables. Metadata is stuff that describes the data in the table. Cool? Okay. All right. All right. So this is a, pretty straightforward thing. Several types of data entities, right? So imagine if you have one of the things, I guess I'll mention, I will do a little bit of a blurb for the textbook. A lot of this stuff from the slides comes straight from the textbook, right? So if you want some amplifying text around any of these examples that I'm giving, the textbook has that, okay? So if you're like, hey, I saw this bit on, slide 24 that didn't totally make sense to me, you can go look it up in the textbook and, get a more expanded answer than what I'm going to give to you. Okay. Anyway, converting to data to information, imagine if you had, a list of names and IDs and majors and GPAs, but it wasn't organized in any way, right? Imagine if you just had a list of numbers or a list of IDs. If you didn't know that it was student IDs, or you didn't know that these decimals, these, floating point numbers were GPAs, it wouldn't make a lot of sense. The data would all still be there and correct, but you'd be like, well, what am I going to do with this? Right? So that's fine. All right. So again, example, data to information, summarize data, somehow data, another example of what can be done with the data that's been processed into aggregates and categories, right? So imagine if you have a massive database. Let's see if I have my thing here. I want to open up a new file. Customer sales. Yeah, okay, we can use this one. That's fine. Okay, so this one, for example, we have a bunch of sellers. We have a long list of orders, right? We got, I don't know, like 500 orders here. Okay, so there's a bunch of stuff. All right. Now, if I wanted to, yeah, you could say, well, all the information you need is here. And if you want to find out, which sellers have been doing the most business, you just go through and you total those numbers up by hand, and it's kind of a slow, painful nightmare. But yeah, you could do it, right? But it's much better, more informative to users to total that up, right? So you could run some kind of query on it and say, hey, for each distinct vendor, show me their total sales, right? So that's a kind of processing the data to be more useful. Okay, and then again, presentation issues as well. You could put it as a chart, you put it as a pie chart or a bar chart or a, one of those XY plots, whatever, scatter plot, whatever. Okay. They talk about metadata. Again, this is just what I said. Metadata is about the data, right? So they say here, properties or characteristics of the data. So things like field sizes, things like allowable values. When I talk, number one, you could be a short last name or a long one. If you have a zip code, does it have to have all 9 digits, or is the shorter 5-digit format acceptable? Can it be empty or not empty? Is it required? Things like that. So those are all examples of metadata. Basically, if it's not something that's the data itself, but either some kind of limitation or constraint on the data or a descriptor of the data, like, you know, a column header, then it becomes metadata. Okay. All right, so the next thing we get to, so that's basically our terms and definitions segment. Questions on any of that? I know all this is more exciting than I promised, but here we are. Okay. So next thing, file processing. So they have a big, long running example in this. I'm going to give a simpler example that that again is one that I've been doing for a while. So they talk, well, I'll talk about what they cover here first. So the idea with file processing is that you have separate bundles of data within an organization that might be used by different users. All right, but I'm going to talk about how this can happen in the context of a real business. Okay. So suppose you start a small business in 1991, basically pre-internet and definitely pre-internet shopping. Okay, so you started this business is 1991, and it's small, and so one guy is both the accountant and the finance guy. Okay, he wears both of those hats because it's a small business. He does accounts receivable, he does finding funding to expand the business, all that sort of stuff. Cool? Okay, so what happens then? The business gets bigger. At some point, the role has to be split for 2, right? So you have one finance guy, one accountant, plus one finance guy equals 2 people. Well, what do you do with the data, right? You don't want to put yourself in a situation, right, where you have, and this is before all that kind of versioning and permission stuff. You don't want to put yourself in a situation where you have 2 guys chaotically and unpredictably interacting with the file, right? This is a problem. So perhaps what you do, you split the data as well, right? The accountant gets 1 copy and the finance guy gets another copy. Okay, so they both have the data. Now, at that instant in time, everything's still cool, right? They both have their own separate things. But the problem is those data are then used by different users and different applications. So what can happen is your accountant can make a change. Maybe, there's some outside process that notifies your accountant that says, hey, our address has changed or our point of contact has changed. And they only contact the accountant. They don't contact the finance guy. So the accountant updates his copy, the finance guy doesn't, right? Or perhaps the finance guy says, this data that I have is good, but it's more convenient to me if I rearrange it in this different way, right? Or if I expand some fields or add a new field, something like that. And suddenly his data structure is different. So if the accountant wants to do some processing with changes in the finance data, they have to run it through a separate application, right? So it becomes usable by the accountant. So what you start having, lots of problems with data inconsistencies, right? Where one batch of data that should be the same thing, right? Both information about the same vendor might, one of them gets updated, one doesn't, right? Data entered separately, but incorrectly, right? If you have twice as many people doing the updates, it is possible that one makes a typo in one field and the other doesn't. Inconsistencies can arise that way, right? Changes to the data schema right? Which is basically all these issues like formatting and arrangement and structure, right? We're just gonna, for now, we're just gonna consider that structure. May render the data unusable by other applications. So what happens is if one person wants to change the data that might, be informally echoed or copied to other systems, right? Not like instantly electronically used, but like, hey, prepare a batch report or give me this stuff on a disk and I'll bring it to my other application. You got to make sure that all the other applications in the business that might be using that data are also up to date, right? So basically, anytime you're changing the data, it's a lot of work to dig through all your systems and make sure that any system that might be using that data is updated. Okay, and again, so what this means, this gets us back to the slides. So problems arise. Different systems have separate copies of the same data, which can lead to these kind of inconsistencies. Programmers have to design their own file formats. They say, oh, I have this data. How am I going to arrange it? Somebody's got to do that, right? Excessive program maintenance. Historically, you might see a large portion of the information systems budget used to just keeping up with these kind of minor changes. If they have a lot of applications and people are doing these kind of changes, this became a real problem in some places. And of course, limited data sharing, right? If you have no centralized control of data, then anytime you want to change something, you have to make sure you find every other thing in the system that uses that same data and make sure it's up to date as well, right? There's no automated mechanism to do that. So it's a big hassle, right? And you can read some of the additional text down here. Most of this stuff is up to date. This is no longer much of a thing now, but they do mention here Excel spreadsheets, which are relatively modern, do fall in the same category as these kind of file systems. So if you are a small business and you're tracking your information in different Excel spreadsheets, well, eventually you're going to have these kind of problems arise and have to deal with them somehow. Now, historically, the way this was implemented, right, a big part of it, ERP, right? ERP, which stands for Enterprise Resource Planning. And basically it means taking all the separate departmental databases and combining them into one common language or structure. Okay. Back to this thing about file data. Imagine this too, right? You have different copies of the data with different structures, and you want to run a query on that data, right? You want to say, show me all the vendors from Philadelphia who owe us money, something like that. If the data are in different formats, you might need to write entirely separate queries for every time you want to do something like that too. Okay, so that can be a hassle. So with ERP, what generally happened back in the day, so this is a similar example to what I use in IDS 200. So you have a manufacturer and you have a wholesaler who wants to, not wholesaler, and you have some suppliers, right? We'll even specify component suppliers. There you go. Okay. Now, prior to the internet, so think circa 1991, what would happen is the wholesaler would, okay, so suppose the question is, can we get 1,000 bicycles delivered by 12/1? Okay. You want to call up the manufacturer and say, hey, we need some bicycles on our showroom floor. Can we, get 1,000 of them delivered, blah, blah, blah. And the manufacturer would say, you call to Susie at the front desk, right? Say, hey, Susie, I want to place an order for bikes. And Susie would be like, yeah, okay. How many bikes do you want? And you'd say 1,000. And Susie would say, okay, I'll talk to the guys in the shop and I'll talk to accounting to see if you owe us any money, if I got to clear any checks. And I'll talk to finance to see what kind of credit terms we can offer. And I'll talk with our component suppliers to see if, this stuff is available. And I'll get back to you in like 3 to 5 business days. Okay. That was the reality in 1991. Okay. Because why? Because all of these different departments in the business, they all had their own separate databases with different permissions. And so what would happen is Susie would relay that request perhaps first to accounting, right, would first say, hey, does this person owe us so much money that we can't even do business with them until they pay us off, right? If that check goes clear, then they can talk to the people on the factory floor and they could say, how many bicycles do we have available for sale right now? How many do we have planned for available purchase by December, shortly before December 1st? The manufacturing guys might have to talk to the suppliers. They say, well, we got 500 now and we got some parts on the way. We'll talk to our component suppliers to see if they can, meet that request. And if they can, if the whole thing seems feasible, then Susie will call the finance guys and say, hey, we have an order for such and such many bicycles. What sort of credit terms can you offer, right? 30 days, same as cash, or, 1% per month. What are we charging here? Okay. And when she bundles all that information back together, she can give them a response. And the reason why she has to do that is all of these databases are very separate from each other. But once you get to the internet era, like circa 2001, nobody wants to wait 3 to 5 business days to get that response, right? They want to just go to a website. They say, type in your order. Well, I want 1,000 bicycles by December 1st. And the system needs to basically instantly give you a response, right? Or at least, fairly instantly respond back to you with an email, something. Okay. And the way they do that is by taking all these different databases that exist in different departments and basically giving viewing access to a lot of outside users. Like they might say, okay, vendor or a wholesaler, you have an account at our business. So you can go in and you can see the state of your account, right? You can't see other people's accounts and you can't see what's going on the factory floor really, but you can, see if you still owe us a bunch of money and you can see your prospective financial terms for this transaction. Likewise, you might, the manufacturing guys, they'll have like end-to-end information that they have 500 bikes available now. They have 250 that are being made, and they have components on the way that should allow them to comfortably make the extra 300 bikes by the time they need to be delivered. You have another thing to your supply chain operation saying, oh, do we have shipping capacity for that? Yes, we do. And all of these people have appropriate accesses to different parts of the one great big database where all this stuff is stored, right? So that's the idea, is you don't want to have a bunch of separate data stored separately. You want to have one system where anybody can go to find the one answer. Does that make sense? Okay. Now, what goes along with this is basically, you'll see a lot of drawings like this in the book. Basic idea is this, right? So I'll do it a little separate. I'll even break it down. The actual data, whatever it may be, has to be stored somewhere. Okay, so we're not going to worry too much about this, but we're going to say this is a database application. Okay, so it's like you have an access file, right? An access file is the data. It's the actual data you have. And of course, it's going to be properly formatted to run through Access, but not necessarily through any other database application, right? So you have the data, which can be sent to the database application, and the database application can, of course, make changes to the data. But there's only one copy of the data, right? This is a good thing. Then you may have many other users who access the same stuff, right? So I'm going to use the example of business departments, right? So you might have accounting, you might have finance, you might have supply chain. Why'd that turn out wrong? I don't know. You might have marketing. They need some stuff, whatever. All those different users use the same database application to properly access this one store of data. And it solves those kind of problems of inconsistency because different people are using updating things separately. There are some issues with what is called isolation. Again, same stuff we covered in IDS 200. So you want to make sure that different users, if they're accessing the same part of the database at the same time, you want to make sure that things don't go wrong with that. But in general, there's one copy of the data, and every different user of that data accesses it through the same application in more or less the same way. Okay. And this works too, even if you chain other applications on top to it, right? So your database application might feed data to, for example, a CRM system, a work scheduling system, right? Maybe your supply chain system, whatever. anything like that, right? So they're all going to be using the same data, even though portions of it might be echoed out to any of these different applications. In the end, they're all still relying on the one single copy of data in the organization. Okay? All right. Let's see what else we got. What do we want to keep going? Okay. So there's a big, long example here with Pine Valley Furniture, but I already kind of covered the same kind of thing. If parts of this seem unclear and you're like, hey, I want to learn more about Pine Valley and their outdated database problems from pre-1990, it's here and you can look into it, but, the basic idea, the basic problems are the same, right? So I'll just do a highlight here. Note 2 different files containing inventory data. One is used for order filling. One is used for invoicing. Duplication is wasteful because it requires additional storage and increased effort to keep all files up to date. Data formats may be inconsistent, data values may not agree, or both. Reliable metadata, difficult to establish in the processing systems, right? If you have different parts of the organization that are given latitude to change the data schema, then of course, eventually some of them are going to do it. And your finance guy might say, hey, I want the data this way. Your accounting guy might say, it makes sense for us to have it this way. That's how inconsistencies creep in. Okay. All right. So again, these are all these same kind of problems that we talked about. Not really much point of going on with that. Okay. All right. So again, the solution, the database approach, this is all this stuff I covered, right? This is basically the same drawing I did in Paint. You have some pile of data, some centralized store of data, which is, again, for any one thing stored in the organization, there's exactly, one copy of it. Or you might say one master copy, and perhaps there are duplicates for reliability, but, they're all going to have the same values. You have one single database management system that accepts that data and where necessary echoes it to users or other applications. Okay, but it doesn't change the fact that there's only one version of the data in your organization. Okay, so here they say database management system is a data storage and retrieval system, right? Storage, holding the data, retrieval, pulling it to look at it, right? Permits data to be stored non-redundantly. That means one copy, right? Redundant, basically, sometimes redundancy is a good thing, right? If we say redundancy for reliability, if you say for every copy of data, I'm going to keep every piece of data, I'm going to keep a triple copy of it so that not only can we, have one available if something goes wrong, but if one copy of the data gets corrupted somehow, we'll have 2 good copies and we can recognize that that's a problem. Okay. So a little bit of redundancy is good, but you don't want to have 2 whole separate master files that include the same data. That would be bad because users might edit one master file and not the other. Okay. So, all right. So yeah, the same stuff. Central repository of shared data stored in one standardized, hopefully convenient form. But the thing is, these kind of apps, right? Go back to Paint. We talked a little bit about the problem where maybe the accounting guy wants data in one format, the finance guys want it in another. The application they use can control that, right? The data exists in one copy. And if the accounting guys say, hey, I want it ordered by names and credit and maybe monthly totals because that's what we work with, then that can be auto-formatted in the data they, receive by default. If the finance guys are looking at some other version of the data, right, they can have their application presented in a different way. It's not a data issue, it's just a presentation issue, and the different apps can handle that. Okay. So pretty much that. So all these are things we're going to talk about in some length over the next couple chapters. So I don't really need to get into those yet, but yeah, we'll have plenty of time to cover those. Okay. So the most common way to handle this kind of structured data, there are other database models used for unstructured data, things like key value stores that, again, talked about in IDS 200, or other approaches. But for structured data, like lists of customers, lists of transactions, relational databases are the main way to do it, right? So I say here, most current databases are in the form of relational databases. The idea, so I'm going to draw a picture. Okay, a couple more pictures. We always like pictures. So imagine if you have table 1. And table 1 is customers, okay? And for every customer, let's say that there are a couple things. There's name, ... whatever. And finally, zip code. Okay. And suppose that there's a second table. Table 2. We'll call zip code. Zip. Okay. And zip codes has the format of zip code and then municipality, right? Basically the city. Okay. So if I want to run a query that says, hey, show me all the customers in Chicago, how would I go about doing that? We did this kind of stuff in IDS 200, right? Sure did. So how do we go about, what do we need? What do we need in our relational database? Don't we need a relationship between the two tables? You're like, yeah, we do. We do need that. Okay. So this zip code field in customers, we can designate that as being fundamentally representing the same thing as the zip code field in the zip codes table. And so what we would do, our step, right? So this is how relational databases work. Number one, designate one field in zip codes as being the same as a field in customers, right? Which would be customers.zip code. Okay. Number two, when the query runs, right? Show me all customers from Chicago. Okay. The software can check each customer's zip code field against the record in the zip codes table, right? And if it's in Chicago, it gets included in the results, right? Eventually, for each check, see if the municipality is Chicago. Okay, and at the end, basically tabulate the set of matches. So that's pretty much it. That's the way relational databases work, right? You have a set of tables, you have some defined relationships between them, and with that information, you can run queries across multiple tables, just like we did in IDS 200. Okay? Cool, this all seems sort of familiar. Okay. Okay. So, one of the things they like to talk about at this point is entities and primary or foreign keys. Okay. So the first thing I'm going to mention, an entity is the kind of thing you are going to represent. Okay. The individual things, though, are called records or instances. Okay. So the entity is the kind of thing, a customer, right? Customer is the table, you know, that's the entity we're going to represent. It's sort of a generic abstract concept. The individual customers, those are going to be essentially instances of type customer. So if you've taken Java with me, it's the same kind of language, right? The entity is basically like a class, and the individual things, like objects, like instances, like records, individual things of them. Okay? Okay. And primary and foreign keys. Okay. So one of the important things, an important thing in relational databases, is the concept of a key field. Anybody remember what a key field is? What is a key field? Why do we have it in our databases? Gosh, when you all shout out like that at the same time, it's really hard to understand you. Nope. Key fields. Yeah. It's true, it does, but what's special about a key field as opposed to a non-key field? Yeah. Yeah. The key field or fields will be unique for any record within the table, right? So something like name, well, let me talk about why uniqueness is important. Uniqueness is important because if you want to say, hey, show me the municipality for the zip code 60607, right? That's Chicago. But imagine if somebody is really fucked up and they put in another zip code entry 60607 and listed the municipality as Iowa City. That's messed up, right? So the way you prevent that is you say, well, I am only going to allow one entry per zip code. So for any zip code value, there's going to be only one record with that zip code. That makes zip code a key field in the table zip codes, right? Because it's unique. So, and you can also do that with more than one field. For example, for customers, it might make sense to have email being a unique identifier and thus a key field, but maybe you want to double up on that. Maybe you can include email and name, right? Because it's possible that people could share an email. I don't know, right? There's other, so anyway, a key field usually is a single field, but could potentially be multiple fields. And if that set of multiple fields is unique for any record, then it qualifies. And the reason why you need it, you need key fields to ensure queries return only correct results, right? If you didn't have key fields, you could have multiple records with the same, you could have multiple zip code records that list the same zip code, but different municipalities, which would lead to errors and confusion and horrible things. You don't want that. You don't want horrible things. It's pretty tautological, but you don't. Okay. Now, that's what a primary key is. So if I just talk about key fields generically, I mean a primary key. The technical proper term is a primary key. However, you can also have foreign keys. A foreign key is a key. I'll do this in blue. Foreign key is a key in another table, like customers.zip code. Okay. Customers.zip code is not a key field in customers, right? It's sensible to assume that many customers could live in the same zip code, right? However, zip code is a key field in the zip code table. That's what makes it a foreign key, right? So for customers.zip code, this is a foreign key for zip code. Here, this is a primary key for zip codes. I guess that should be zip codes. Okay. Primary and foreign keys. All right. Here's some other stuff. Here's some pictures that are not in the chapter. Okay. There's different ones. So relational databases are primarily what we're going to talk about. Key value pairs are useful. Some of these other ones are useful. Document storage systems. If you took IDS 200 with me, we talk about a bunch of more detailed models, like how YouTube stores video chunks, or how YouTube does indexing, not YouTube, Google does web page indexing, things like that. So there's a bunch of different alternatives to relational databases. I'm going to take one more minute, and then we'll come back and wrap this up on Thursday. But I do want to mention something. Just okay. So some of you may be wondering. Okay, so in a relational database, it is very typical to force all records in a table to have the exact same format, right? Things like same data type, for example, text versus integer versus floating point number versus date, etc. Okay. And the same size. Okay, so 20 characters etc. Okay. This is very common in relational databases. If you've done Access, this is the default setting for Access. If you include a field in a table, you specify the format of that field, and every record has to obey that format. Okay. Reason is, it makes it fast. It makes lookups fast. This makes looking up data fast. For example, right? Suppose you have a table called customer with customer records, and the two fields are, the first two fields are last name and first name. Okay. Last name occupies, let's say, 60 bytes. First name occupies 40 bytes, right? However those characters are stored, that's the limit. And the total volume of each record is 1,000 bytes. Okay. Cool. All right. Well, if each record is 1,000 bytes, it's very easy to plan around storage requirements, right? Just like, you say, oh, I have a 1 terabyte capacity hard drive. I can store 1 billion records on that. Great, right? Stuff like that. If I have more records, then I need to have more disk drives, whatever. Also, when looking up data, you would know that each first name field would be offset by 60 bytes from the record start. Okay, so record 0 starts at byte 0. First name starts at byte 60, right? Likewise, record 1 starts at byte 1000. First name starts at byte 1060, right? Etc. And so when you have an application that's scanning through things to find this, it doesn't have to scan through the entire record, doesn't have to scan through the list of stuff, say, hey, is what I'm looking for even in this record? If it is, where do I find it? No, the memory, you just load the table into memory and you say, oh, here's where I check. I check address 60, I check address 1060, address 2060, address 3060, and so on. So having this kind of regular structure allows the operations of finding data to be much faster. Okay, it's a useful thing. But this is why that constraint is generally enforced in relational databases. Strictly speaking, it doesn't have to be, but it's unusual to see it when it isn't. Okay? All right, cool. Well, that's all I got. This is a good break point. We'll finish chapter 1 on Thursday and enjoy. All right. What's happening? Hello. Okay.
On the attendance,
Yeah.
a thing, syllabus, it says like something like attendance, like 5%.
Yeah, there is a small attendance penalty, but I'm not going to track it that closely for the first couple weeks because late people might be joining.
Okay, so is that gonna be like through